In SAP BRIM, pricing logic does not travel down a single monolithic pipeline from order to invoice. Instead, data splits into three separate pipelines. The exact ABAP object chain a price follows is dictated entirely by its commercial structure, whether it is a one-off charge, a simple recurring fee, or a complex usage-based rate. The journey always begins with a commercial selection made in the Subscription Order Management, or SOM, user interface, and it must always terminate as a finalized, standardized financial receivable posted in the Contract Accounts Receivable and Payable subledger, known as FICA. Connecting these two endpoints requires passing through two intermediate routing engines, convergent charging and convergent invoicing. We are going to trace the precise ABAP payloads, database tables, and function modules across all three pipelines, layer by layer. Mapping this object chain is the only way architects can guarantee that highly variable pricing models consistently collapse into a compliant financial receivable. This diagram maps the architecture, and before any pricing pipeline can execute, two master data anchors must exist in S/4HANA. First is the business partner. This is created either by passing data through the BAPI BUPA Create from Data function module or via the Business Partner OData API. This business partner must hold a specific role to function in BRIM. The MKK, or contract partner role, is an absolute prerequisite. The second anchor is the contract account, which utilizes the FKK KOTO number range object. The contract account carries critical parameters that downstream billing relies on, specifically the account determination ID and tolerance groups. Most importantly, it holds the invoicing category and the billing cycle. These two parameters directly govern how invoices will be routed and timed. If these master data anchors lack the MKK role or the correct parameters, the convergent invoicing layer will categorically reject any incoming billable items, breaking the chain before billing even begins. The first pipeline handles one-off fees, like activation charges or hardware bundles. As this flow shows, the price originates here as an SD condition record, such as condition type PSPB, stored directly in table CON-P. When the subscription order uses a specific item category, like PROF, it triggers a processing block known as the Order Distribution Infrastructure, or ODI. Within the ODI block, the specific ABAP execution is handled by step classes 1F and PCOF. These step classes pull the SD condition and translate it directly into convergent invoicing. To do this, the step classes post the data using CI posting areas 8170, 8171, and 8172. The output of this process is a generated billable item, or BIT, resting securely inside convergent invoicing. This ODI pipeline acts as a direct bypass. It translates flat SD conditions into CI billable items immediately, avoiding the computational overhead of recurring logic or rating engines. The second pipeline processes simple recurring fees configured without complex consumption logic. These fees originate from a different SD condition type, such as PSMB. Instead of triggering ODI direct generation, SOM passes this recurring condition payload directly to the CI billing plan. The CI billing plan looks at the contract account's established billing cycle to periodically generate billable items. To differentiate these items, the system tags them in the Source Transaction Type field, or SRCTA, with the specific identifier BIP. Routing these fees through the CI billing plan decouples basic cyclical charges from convergent charging. This preserves convergent charging's processing power exclusively for actual usage rating. The third pipeline handles usage-based fees and complex recurring charges that require external rating. The primary technical challenge here is translating a front-end UI characteristic, like an advanced variant configuration selection, into a mathematical parameter the rating engine can compute. This split-screen schematic illustrates the solution, cross-catalog mapping, or CCM. This translation is executed via the class method crms4sm.seom.spec.prod.update. CCM binds the convergent charging service ID to technical resources, like a phone number or an equipment serial number, ensuring incoming usage records route to the correct provider contract. Once routed, convergent charging executes its rating process by passing unrated chargeable items through decision trees known as charge plans. The immediate output of this rating execution is the charged item. For the final leg, the CI bulk loader imports the charged item, translating it into a billable item stamped with the source transaction type CCCIT. Cross-catalog mapping serves as the critical translation layer of SAP BRIM. It is the specific mechanism that allows dynamic front-end commercial selections to drive complex back-end mathematical decision trees. Standard pipelines handle standard fees, but complex discounts determined via B2B master agreements introduce an anomaly. These discounts are rarely flat condition types. They frequently require consumption to be aggregated over time before the calculation can occur. To handle this, BRIM utilizes a distinct technical structure: base items. Looking at this database blueprint, we see these base items rely on the interface component disk agreement and carry the source transaction type DISC-BRE. During the billing process, convergent invoicing automatically evaluates these condition-relevant base items, applying the necessary calculation rules prior to creating the final billing document items. By using base items, SAP BRIM supports highly complex, tiered, or time-independent B2B discount calculations without hard-coding custom logic into S/4HANA SD. As this architecture map shows, despite originating from three entirely different engines, ODI, the CI billing plan, and the CC bulk loader, all payloads have now converged. Whether the source transaction type was BIP or CCC_IT, the FICA subledger now processes a structurally uniform data row. Initially, these generated billable items sit at status 0, meaning raw, or status 2, meaning billable. This item creation is driven technically by the asynchronous FKK BIX BIT create API, or system-generated function modules, under the /1FE/namespace. Next, the CI billing process selects all status 2 items, applies grouping rules based on the contract account parameters, and aggregates them into a billing document. This billing process shifts the status of the original billable items to status 4, meaning billed. The final transformation occurs when the CI invoicing process consumes that billing document to generate the final customer-facing invoice. This invoicing process triggers the actual financial posting, writing the receivable into the FICA subledger and seamlessly integrating it with the general ledger. At this point, the order-to-cash object chain is complete. The strict structural enforcement of the convergent invoicing layer guarantees that, no matter how complex the origin logic or ABAP routing, every fee collapses into an auditable, compliant FICA receivable.